Greatest integer function. What is greatest integer function? Actually, often in questions they will define us some functions, and this is one of the most common kind of functions. Suppose we are given box of sum 2.3. The value of this will be 2. Every real number x is having two parts. One is the integer part, another is the fractional part. Every real number x has two parts. This is the integral part, which is denoted by this box of x, and this is the fractional part, which is denoted by this symbol. Now what does the symbol signify at all? Say for example another number 3.3. We can write it as box of 3.3 plus fractional part of 3.3, which will give us 3 plus 0.3. This is the fractional part. This is the greatest integer less than or equal to x. Yes, greatest integer less than or equal to x. Which means box of x, the greatest integer function. This function as a machine, if we consider, gives us the greatest integer which is less than or equals to x. This box of x always belongs to integers. Now when they will be equal? Suppose x is 6, then box of x will be 6. These are some of the common definitions or illustrations. The greatest integer function is represented or denoted by box of x. For any real function, the function round of the real number to the integer less than the number. This function is also known as floor function, also known as step up function. So this is some of the elementary information regarding the function. Now this is what the graph of the functions looks like. This is the graph of the function. Say when we put the value of x, this is 1. When the value of x is say 0.3, the greatest integer less than 0.3 is 0. So we can see that in the graph, any value less than 1 we are getting a value as 0 only. Say 0.5 here. This is also 0. 0.8. This is also 0. The box function. Now what happens when box of x equals to 1? When box of x equals to 1, the value of the function will be 1. So at this point, the function will be discontinuous. At this point, the function will be discontinuous. This is very important. Box of x equals to 1. This is 1, comma 1, this coordinate. And here, this point is 2. Here also the function is discontinuous. Now why the function here is discontinuous? Because we know that box of 2 is equals to 2, but here the graph corresponds to 1. That's why here also the graph is discontinuous. These are some of the important things, crucial things that we need to understand. Now we have seen that this box function is defined for negative numbers also, because x belongs to real numbers. Now what is the scenario in negative number? Say -1. Say for example -1, -2, which is greater among them? Clearly -1 is greater than -2 because they're negative here. So box of for negative number, box of -2.3 will be equals to -3, because we know that box of x is always less than equals to x. With this definition in mind, greatest integer less than or equals to x. Box x gives us the greatest integer less than or equals to x. Just simply compare between -2 and -3. What is the greatest integer? Clearly -2 is larger than -3, because here this time they are negative. That is the key point to be noted. So in this case, the greatest integer less than equals to -2.3 is -3, because if we take -2, say for example, if we consider -2.3 box as -2. Now according to the definition, x is always greater than equals to box x, but in this case -2.3 is less than -2. -2.3 is less than -2. That's why this is the wrong case. That's why this is the wrong case. From this definition, if we move ahead, then what will be box of -3.3 plus -3.3? we know that this will be equals to x, because x is equals to box of x plus curly function of x. This fractional part, this symbols denotes the fractional part, can also be said curly function. And we have seen that every real number is having two parts, one integer part and one rational part. Now where does the fractional part lies between? If we follow the definition, this value will be -4. So this value needs to be 0.7, which will give us -3.3, From here, we can deduce that this curly function, whether x is negative or positive doesn't matter, is always greater than or equals to 0. Now when it's equals to 0, whether we put x negative or positive, because here in this case x was negative, this was -3.3, which is a negative number. But for the fractional part, if we can see, then the fractional part is positive, right? So here we can deduce that fractional part is always greater than equals to 0. Now in which case fractional part will be 0, when this x will be an integer. We will discuss this elaborately in fractional part. So now let's focus on the graph of greatest integer function, rather. Graph of greatest integer function in the case when it is negative. Any value, say -0.1, this will be what? -1. Just now we have seen the cases. So for any value in this region, say in this region, here the point is discontinuous again, here this point is discontinuous. For any value, this corresponds to -1. This is equals to -1. This point is again discontinuous, because when box of -1 will be equals to what? -1, right? So this point is continuous. This point is continuous. What is the discontinuous point? Is this point. Because if we extend this, it will meet at -1. But we know that box of -1, since it is an integer, will be -1. Box of x equals to x when x belongs to integer. No matter, let it be positive, negative or whatever, that doesn't matter. Positive, negative or whatever, that doesn't matter. So here we have seen the discontinuous point. Now let us mark all the discontinuous points in this graph. This point, this point, this point. This point, this point, this point, this point. If we draw a straight line, then this will be a straight line, I guess. Okay, let it be straight line or whatever. These are the discontinuous points in the graph. Another important thing to note from the graph is that it's like a step up function. You just see, this is something like steps, right? That's why it is called step up function. This was all about greatest integer function. It's hardly visible. The fractional part or decimal part, let me make it more elaborate. The fractional part or decimal part of a non-negative real number x. Wrong definition. Wrong definition. The fractional part or decimal part of a real number x is the axis beyond that number's integer part. So now it's correct. The fractional part or decimal part of a real number x is the axis beyond that number integer part. Let us define it more properly. We have seen that x is equals to box x plus curly x. This function is denoted by this symbol. This function is denoted by, oh, it's not visible, right? This symbol. This it's happening. This symbol. Any number x can be written as this box x plus curly x. So we can say that curly x is equals to x minus of this x box x, which is the greatest integer function. So this is what? This is the axis. This is the axis beyond that number. That was a simple thing that we need to understand. Now what will be the graph of this function look like? Just let us try to make it ourselves. Say a input we are giving. Sorry. Box 0.3. This will be 0.3, right? So let us take some numbers. 1, 2, 3. For any number here in this region, when I am taking 0.3, when I am considering 0.3, this will synchronize to 0.3 point only. So this will be a straight line up to 1, right? Because this, just a minute, curly x, let me put some value, say 0.5. This will give me 0.5. 0.3. This will give me 0.3. So up to 1 we didn't need to worry, because 1 is an integer, and whenever this x is an integer the function will be discontinuous. We will see this. So up to 1, say this point is 1, the function's graph will look like this. Now what about the points? What will happen at the point 1? 1 can be written as box 1 plus curly 1. Box 1 plus curly 1. This curly will become what? This will become 1. This is 1. So this has to become 0. So whenever x belongs to integer, curly x equals to 0. Write this as an important note. It's very important. It's obvious from the definition, but if you are having some difficulties in interpreting the definition, that you can write. So at this point, this function will be discontinuous at x equals to 1. From 1 afterwards, 1.1 will give us what? 0.1. Say somewhere here we will get 0.1. 0.1. Sorry. And 1.3 will again give us some 0.3. Say somewhere here we'll get 0.3. So this will again be a straight line, discontinuous at this point. 2. From 2 also similar scenario, from 3 also similar scenario. Now what about the number in the negative side? What about the numbers in the negative side? These points are discontinuous. What about the negative side? Minus 0.1. Those who are still having some kind of difficulty in understanding this, for the negative case, first try to interpret this. X equals to box of x plus curly x, which implies that 0.1 minus 0.1 minus 0.1 plus minus 0.1. This will give us the greatest integer. Here this will not be 0, because 0 is greater than 0.1 and box x is always less than x. So this will be contradictory case. That's why this will not be. 0 is always greater than minus 0.1. But we know that x is greater than box x always. This is always true. So here the greatest integer less than 0.1 is minus 1. Very simple. So this curly x will be here 0.9. Add them, we'll get minus 0.1. It satisfies. So what can we deduce for this curly x? This is very important property. In fact, some good questions in Olympiads can be formed from this kind of simple properties. We'll show them in the practice session. Say x is minus x is 1 minus box x. X. Now let's see whether this is working or not. This property, you can see this is experimental property and it is always true. We cannot give a proof that y 1 plus 1 is equals to 2. And this property is also such kind of obvious. You may not be getting the feel for this property Right at this moment, you may not feel this property, but after solving few problems and focusing on the illustration, if you're doing this function for the first time, you'd get some hint, and in the next session, you'll become a kind of expert for this greatest integer function and fractional functions. Like when we're learning 1 plus 1 for the first time in our life, in the nurseries, when we're learning 1 plus 1, we're not that expert in addition at that time, but gradually with time we're learning, and this is also like that. Now if somebody asks us why 1 plus 1 equals to 2, we won't be able to prove it, and this is also similar kind of obvious thing. This is obviously true. So let us give some examples to have some clarifications regarding this. Minus 0.3, this will be 1 minus 0.3, this will be 0.7, right? Not understanding, sir. See, minus 0.3, box minus 0.3 plus curly minus 0.3 minus 1 plus 0.7. Obviously now, because what? You just see x is what? X minus box x. So you get this 0.7 obviously. Here also we are getting this. Now we will see that whether this is true for negative number also. Formula is this: put x equals to minus 3. Put x equals to minus 3.3. Let us see. Box of minus 3.3. You just see 1 minus 3.3 minus minus plus. This will be 3.3 here, 1, and what will be the box of this? 0.7, right? 1 minus 0.7, 1 minus 0.7, this will be 0.3, and this is what? This is also equals to 0.3. So this rule is true for all x belongs to real number. This property is true for all x belongs to real number. All x belonging to real number, right? Now let us again focus on the graph. This is the graph. We have already shown it. Now for the negative numbers also this will be clear. These are the points for the graphs are discontinuous, right at the integral points, because for integral values the value of the graph becomes 0. Sometimes I'm saying that if you're supposed to find the integration is what? Area under the curve. You can easily calculate the area under these curves. These are simply triangles. Sometimes if such mixtures of questions are asked that how many solution does box x, let me give you a question directly from the graph. Yes, got it. Let us go for some easy basic properties before starting the questions. Some basic properties of not visible properly, right? Okay, I've made it visible. That is not a great deal for me. That's not totally visible. Some basic properties. This property we have already seen. For any value, this curly x fractional part is always less than 1, greater than equals to 0. This is equals to 0 when x belongs to integer. This we have already seen a lot of time. If and only x is integer. These are some important kind of inequalities which we will use, and these are obvious inequalities definitely while solving some problems. Minus x, here we say that this is universal, but this is not universal because when x is an integer the function is discontinuous. Oh, this is for the box x part. I thought that this is for the curly x, right. Just focus, this is for the box x also, similar kind of property holds. Whatever for the box x or other x doesn't mean anything to us. This when x is not integer, and this is equals to minus x when x is integer, when x belongs to integer. And this is the famous triangle inequality. This is the famous triangle inequality. Where is it? This is famous triangle inequality. Just write it down properly. All of these are equal. These are equally important. This triangle inequality can be generalized. Actually, this is not triangle inequality. Triangle inequality is what that is taught in absolute value function. This is a kind of obvious inequality. Since x is what? Greater than box x. Therefore, x plus y, when we're taking the sum also, is also greater. These are also some obvious inequalities. One important point that they have missed. For box x is, just a minute, sorry. Minus x, two functions. This is how we are defining the partwise or the piecewise function. This is equals to 0. Minus x will also be equals to 0 when x belongs to integer, and when x doesn't belongs to integer, we have already discussed this a lot of time, so I hope you not forgot this. Okay, this is also very important, equally important. Now box has some other obvious properties that they have missed. Let me write. You cannot even imagine how important is the property that questions in the topmost national Olympiads exam can be asked from this easy looking properties. N belongs to natural number. Now I want to know that whether it's true for integer also. Let's check for a negative number. If it's true, then it's okay. Let's check for a negative number. Yes, so this is true for any integer. Here n belongs to integer. This concept of natural number is wrong. N belongs to integer. This property is very important. Based on this kind of simple properties, questions can be asked in any Olympiads. Here another important thing from this property, that minus x plus 1 minus curly x, we can get minus x not belongs to integer, then equals to 1. This is also an important thing. Just write it, because at the time of examination these things needs to strike your mind so that we can solve problems quite easily. This was all about the definition kind of thing. Now let's focus on some questions. Today our focus was basically on theory. We'll focus on question the next day. The first question: draw the graph of box x square. Draw the graph of box x square. Okay, this will be a more tougher one for you. Just a minute. No, I guess that this will not be a tougher one for you. Box x square is easy only. Yes. Draw the graph of box x square. I hope that you all have drawn the graph. I'll show you for one side, another side you can easily draw. One, I'm just giving the hint, take such kind of interval. 1, root 3, root 4. Since this is x square, take such kind of intervals. When x lies in this region, 0 to 1, the value we will get is what? In between 0 to 1. When x is 1 to root 2, the value we will get in the 1 region. Here this signifies 1. At this point, remember, the graph is discontinuous. Similarly, for root 2 to root 3, root 2, here this point will be 2. At this point, the graph will be discontinuous. In such a way, draw the graph. For the other side also, this will be vice versa, because x square is always positive. This will be the graph, something like that. Now, based on the simple concept of graph, very nice, beautiful, elegant questions can be formed. This is the graph. You can have a look. The approach is same only. Here just the graph looks quite official. Now, based on the simple concept, solve a question. Solve a question. Find the number of, okay, before that, let's solve some easy question. Let's solve some easy question before that. Find greatest integer function and fractional part. A, B, C minus 2.111 minus 0.91993 4.01. These are the GIF, and now I'm giving you for the fractional parts, minus 0.3, minus 3, then minus 3.3, then 4.3. Solve this very fast. Okay, I hope that you all have solved. This will be what? This will be minus 3, this will be minus 1, this will be 3 only, this will be 4, and what will be this? This will be 0.7. Just use the property of fractional part of minus x, you will get it. This will be minus, yes, this will be 0, correct. And what will be the value of this? 0.7, and this will be 0.3. So these are all your answers. I hope that the basic concept is clear now. Graph is also clear. Now solve a question from KVPY 2020, one of the latest questions. Find the number of real solution. Find the number of real solution to this equation. I hope that it's clear now. Just draw the graph of box x square. You have already drawn the graph, and draw the graph of x plus 1. This is very easy. Draw the graph of y equals to x and make a vertical shift because this is plus 1, and find out the point of intersection. At the point of intersection, just look at this graph. This is the graph. These are the point of intersection. At the point of intersection exactly, the graphs are what? Discontinuous. This will be discontinuous, right? Why this is discontinuous? Let me give you the reason. That when x plus 1 equals to 3, x equals to 2. But when x equals to 2, this box x square will be equals to 4. Right? So at this point, the graph is what? Discontinuous. Similarly, at this point, the graph is also discontinuous. And after this, you see, box x square will be steeper and steeper. Will be more steeper and steeper. And the slope of this will remain constant. So there are no other possibilities of intersection. Hence, the number of solution, real solution, is what? 0. Crystal clear? Okay, fine. Now let's solve box x square is done. Now let's solve an easy question, not from the concept of graph. If the handwriting is not clear, I am reading it. Fractional part x whole square minus 3 fractional part x plus 2 equals to 0, and box x whole square minus 2 box x minus 35 equals to 0. Find all possible x. This is very easy. Just solve this equation. This is having two roots, 1 and 2, minus 1 minus 2, right? And this is having minus 7, 5. Minus 5, right? Minus 5, 10, 35. Yes, yes, yes. Just consider this curly x. Just consider this curly x as a. So solve this equation. You will get two values, 1 and 2. Now the interesting thing is that in this kind of question, okay, and this is having what? Two roots, minus 5 and 7, I guess. 49 minus 2 times, I'm really poor in calculation, 35, 39, 49. Yes, yes, yes. These are the two roots. These are the two roots. Now the interesting thing is that some would say that x should have 4 values, because here we are getting 2 real roots and here we are getting 2 real roots. So the possible values of x are 2 into 2, 4. Or they will add them up and give us the values of x. Interesting thing is that we are getting curly x equals to 1 and 2, and curly x is always less than 1, greater than equals to 0. Less than 1, greater than equals to 0. So is this two values of curly x possible? Not yet possible, right? So x has no real solution. X has no real solution. Why? Because x is simply curly x plus box x, and curly x is not having, oh, it's not visible, right? Curly x is not having no real solution. So x will have no real solution, right? Okay. Now let me give you a good question. X square equals to 256x. This is question number A and question number B. Okay, just solve one question at a time. Have you solved it? Okay, I guess that you have solved it. Just we have the famous inequality, which proves really useful for us. When multiplied by 256 will lie between 256 and 0. Just multiply because this is positive. the inequality signs doesn't change, and this part is what equals to x square. Here you have to find number of solution. Okay, here you have to find number of solution, because finding the solution is near about impossible. Here also you need to find number of solution given the condition x greater than 0. Okay, the question was incomplete, and I have given you the major hint for those who couldn't do the question. You need to find positive. How many positive solution does the equation have? X greater than 0. I have given greater than, not equals to 0. Greater than 0. Strictly greater than 0. So, important thing that we have already, I'm giving you the solution now. Important thing that we have already deduced is this. This is what? 16 square, right? So, what are the possibilities? How do the graph of this function look like? Let me draw the graph for a crystal clear understanding. Where is our graph? Just let me bring it here. I can't bring it here, so I need to draw the graph. That's better. We have already seen the graph of curly x, which is something like this. Now when multiplied by 256, the entire graph, graphs, what changes in the entire graph? Can you see? The range changes, obviously. So earlier, here, this upper portion values, this upper limit, we can say, was 1. Now this, when multiplied by 256, the upper limit will be 256, and we know that the graph will be discontinuous in case of integers. So this will now be more steeper, like this. This will be the new graph. Now let me draw a better picture. This will be the graph, new graph. This value is 256. Here the graph is discontinuous. Now what does the graph of x squared looks like? We all know this. I hope that you all know this. Oh, here also the graph will be like this. In the negative part also. And we want only the positive roots. This is how the graph of x squares looks like. I hope that you all know that graph of x square is something like this. Again, it's not visible. Let me draw it here. This is how the graph of x square looks like. So here we are only eager with the positive solution. So I am drawing for the positive side. This will be something like this. So in every place when the two graphs are cutting each other, will give us a solution, right? And the upper limit is 16. There is an interesting thing that here also the graph will be cut in this line also. But when exactly will come such kind of a point when the graph will be discontinuous? Just I am drawing that case because it's not possible for me to draw the entire graph. I'm just giving you the hint. How many cut it will make? Like this. Up to what? Up to, if I say up to 16 only we want, and x square will cut through all this like this, because these are very steep. Okay, these are very steep. I can't draw it here. That's why this will cut. X square is also steep, but these graphs are also steep. I'm not drawing it like that way. That's why it looks like this. This is 256. Up to 16, x square will cut. Now let me draw it more steeper. For the last case I'm drawing. So why it's happening like this? Just a minute. My system is not working properly. Now it's working. This will be the graphs. Looks like very steep graph. Now add the case. In this case, just look properly. Just have a look properly. It is disgusting. This point is what? 15 to 16. From 16 onwards also, the graph will be like this up to 17, and from 15 onwards also the graph will be like this. And if I draw vertical line, okay, this point the graph is discontinuous. Just focus this point, the graph is discontinuous. But what about the graph of x square? This will cut through this point, right? At this point the value is 16. This value will be what? 256. This is 15. This is the graph of 256 curly x. At this point curly x is discontinuous, but this x square's graph, this graph of x square is not discontinuous at this point, so it will cut through. But here this function is not defined, so this will not be considered as a root. Before that, you see this 14 to 15 interval, here this will cut, 13 also, here this will cut, here this will cut. So the number of solutions are, this was the 16th cut, I can say. The one's graph is also cutting from 1 to 14. How many solution? From 1 to 14, because at 0 also we have strictly mentioned that x is greater than 0. So the case when x equals to 0 is also not admissible. So the number of solutions are 1, 2, 3. The number of solutions are 14. Number of solution are 14. Because at 0 and 16, this is not happening. Yes. Now let's move away for another question. Let's move away for another question. Similar question, which will be extremely similar question. Same idea also. 2 to the power x equals to 256 box x. This will be your homework. Write it, write it. Curly x, curly x. This is curly x. Answer is 7. Answer is 7. Number of roots. Yes, find the number of roots. Find the number of roots. Answer is 7. Now let me go for easy kind of question, typical kind of question in every kind of JEE preparation lecture. This question is solved. Find the value of s equals to 1 by 3 plus 1 over 2021 plus 1 by 3 plus 2 over 2021 up to plus plus 6024 over 2021. I'll just give you a hint, even I did not solve the entire question. Now it's visible. Find the value of s. Here there are some dots. One by 3 over 1 over 2021, 2 over 2021. This is 6024. 6024 over 2021. You need to find the value of this s. Actually, this is also a brilliant question. My handwriting is really poor. I cannot do anything for this. It's extremely poor. Even when I am writing in the copy, it's really that kind of poor handwriting. I'm just giving a hint that you need to find up to which term. This is 1. Okay. This will be 0 up to which term? Just see. 1 by 3 plus n over 2021 less than 1, right? 2 by 3. Two into 2021 by 3. 2021. 4 for 5. It's not divisible. 2021 is not divisible. Here also you need to go for the box value. I'm just saying box value. So up to n terms. For n terms, if you get the value of n and you'd get some fraction, you take the box value of that fraction and try to think like this. Up to n, when this expression is less than 1, this expression is less than 1, the value will be what? The value of this will be 0. The value of this will be 0. The value of this will also be 0 up to 1. Then consider the next case. From n plus 1 to such kind of number when the value is less than 2. When the value is less than 2, and find out how many numbers are there like this and solve this problem. If you are not getting what do I mean, I'll solve a easy question. I do not want to solve such kind of lengthy calculation kind of problem. Two by 3 up to 1 by 3 plus 15 by 3. Just observe, this term is equals to 0, this term is equals to 0, and then the next term will be what? 1 by 3 plus, this term will be equals to 0. I am saying you are believing. There is a splendid symbol denoting so on. Okay, so on. 3 dots are there. This term will be equals to what? This will be equals to 1 by 3 plus 2 by 3. Now you just see 1 by 3 plus 2 by 3, 3 by 3, up to what? Up to 5 by 3. 5 by 3 will be what? 5 by 3 will be 2. So from 2 by 3, 1 by 3 plus 2 by 3 to 1 by 3 plus 4 by 3, the values of this term, when we will take the greatest integer function, up to this will be 1 only. Are you getting the logic? This is 4 by 3. But when we get this case 1 by 3 plus 5 by 3, this will be 2. Now find out for how many terms this will be 2, then find out for how many terms this will be 3. In the very similar approach, solve this question. This is an easy question, easiest question. If you can't solve this kind of question, Olympiad is going to be a difficult thing for you. All the questions that I thought I may not be able to solve. So, one question that I want to solve now is this. Find the unit digit of this expression. This question was asked in China 1993. Find the unit digit. This is 93. 10 to the power 93, and here it is 10 raised to the power 31, and this is 2. For this question, I hope you have tried and find the last 2 digits. Find last 2 digits. This is a very good question. Will clear all your concepts. Yes, this will clear all your concepts. That is all your doubts. Now, how do you solve this question? Let me do it fast. It's already 70 minutes. This question is based on this property. Nothing more I will say. As a hint. Nothing more I can say. Now just see. Simple iteration. I guess you all are aware of that a cube plus b cube formula. Yes, simple things comes in Olympiad. Consider 10 to the power, just a minute. Consider 10 to the power 31 whole cube. This will be 93 plus 3 cube over 10 to the power 31 plus 3. We have added a plus 3 cube. This needs to be subtracted right away so that equilibrium is maintained. 3 cube over 10 to the power 31 plus 3. Box equilibrium maintained, plus minus. Here we have added, here we have subtracted. Now using this a cube plus b cube formula, the very simple formula, we get 10 to the power 31 plus 3 into 10 to the power 31 minus, not 2, 10 to the power 31 into 3 plus 3. This will be what? Square. This will also be square, divided by 10 to the power 31 plus 3. So these terms are cancelled out. This means that what? This part belongs to integer. This part belongs to integer. And the property that we have learned of n plus x is valid here for this case. So I am applying this box here. Because this is integer, this property can be applied, and I am also applying this minus this 3 to the power 3 over 10 to the power 31 plus 3. Clearly this expression is very large, 10 to the power 31, and this is only 27. So this will be some 0.00000 something, which will give us, because this is box greatest integer function, this will give us 0, right? No, this will not give us 0. And why it should give us 0? Why it should give us 0? This will be plus, and this expression is what? Negative. Now this is correct. Now this is correct. We cannot change symbols like that way. Okay. And this is what? Integer. What about the last digit of this integer? This is what? Some 10 lakhs, like that. More than 10 lakhs, billions, million, trillions, millions, minus some 30 million, like this. And we are asked just the last two digits, which are not that significant. And this 3 square is what? 9. And this part will be what? Minus 1. Minus 1. Because this will be some 0.0000 like this. Minus 0.00 like this, which will give us, on finding the GIF, this will give us minus 1. Now, the last digit of this expression will be what? Some 10 minus. The last digit of this expression is what? 9. Some 0.0009 minus 1. The last digit from this expression. This will give us some 0.00008. This is what? 9. That's why we are getting this 9. And here this will be in zeros. Let it be what happening that doesn't mean. There are so many zeros. I have written less. There are so many zeros even in this 3's thing, and in 10 things also there are so many zeros. That doesn't matter. So this will be some 0.0000000 like this. Not 0 point. Some 000. Extremely large number. Last two digits is what? 09, minus 1, 08. even if they have asked 08 or the last 3 digits, this is also 08, last 4 digits, this is also 0 times. So the last 2 digits are 0 and 8. This problem will become more clear in the next session when we discuss a similar kind of question based on some other international kind, not international, national level language, or more than national level, less than international level. I'd not go for that kind.